Hello, everybody. My name is Mustafa Ihsan. I'm a mechanical engineering student at San Jose State University. And today I'm going to talk about the Hyperloop, which is my senior project. And I am part of the lateral stability team. So today I will talk about the background about the Hyperloop and the motivation and the sub-team about the Hyperloop project. And the main thing I will talk about the lateral stability mechanics and design. And in the end, I will go through some analysis and conclusion. So the Hyperloop, it's very unique and amazing technology that's been under developing. People expect Hyperloop will be able to travel within the speed of 300 to 500 kilometer per hour, depending on the design. To understand what's the Hyperloop, it's pretty much a technology that transfer people with the intense speed, but it depends on two facts, which is the friction and the power. So to solve these two issues, the engineers came up with some ideas. To avoid the friction, they use magnetic leviation and vacuum tube. So there's supposed to be virtual no friction. And we will be able to send the Hyperloop pod in the intense speed with no friction. That's how to solve it. And for electric power, we will be using a solar panel on top of the tunnel, and that gonna makes the Hyperloop power itself in a clean way with zero emission. And that's the purpose of using the solar panel. Also, the Hyperloop it's not just gonna be a high speed train, it's gonna be more affordable and easy to travel. So this technology will be very useful for people and they will beneficial from it. Still until this moment there is no a human transportation Hyperloop yet. There is some for shipping, but not for transportation yet because of the safety concern and the restriction that every country has. So right now we're just working on research to improve the design. In order to know what's the Hyperloop, it's made of three parts, three main parts, which is the pod and the pipe and final thing, the powertrain. As a mechanical engineering student at San Jose State, we are only allowed to work on two parts due to the research and development. So we can only work on the pod design and the powertrain. And as a mechanical engineering student, we are only working on the design. And there is a different two teams, mechatronics and electric hardware, working on the powertrain. We have decided to go with the Hyperloop project not just because it's interesting and new things that the world has not been experienced yet. It's because of the challenge and the issue that we will face. So this will give us a real life problems issue, which is make us more experienced than other. On top of that, it will be interesting to know that in the future you will be one of the people who helped to develop something like that. The Hyperloop can help the traffic issue and solve the climate change issue by reducing the emission of carbon dioxide. And on top of that, it will be cheaper. People expecting to have a cheaper transportation and faster at the same time, which makes it unique. So we decided to go with this project for so many reasons, but these are the main reasons that I would appeal to my heart. So the Hyperloop project that we have in San Jose State split to different teams. So we have a chassis team, aeroshell team, battery team, a drive system team, and suspension team, and we are the lateral stability team. So our main concern and subject that we need to stabilize the pod on top of the rail while traveling, especially when there is a curve. In a straight case, there should be less drifting, but when there is like a turning in, around the Hyperloop, that will be a problem. So we have to make sure everything is stabilized. So for our team, we have to find a mechanism to stabilize the Hyperloop pod. And one of them that we came up with from a real life design, which is the car suspension, because the car suspension exactly does the same thing, but the only difference with us, it's not connected to a wheel. It's going to be a little bit different, but we're using same concept, which is the shock absorber, some fastener, some connector to the body to maintain the speed and the same direction, so there is no drifting to any side. So for us, we decided to select three different design, and we came up with the final one that you will see by the end of the video. This design that we came up with made of four parts. So two fastener that connected the whole system to the chassis of the Hyperloop from the back, and two three body diagram, and one shock absorber, and one poly wheel. So connecting all these together makes it similar to the suspension of the car, but a little bit different concept. But this will help to apply pressure on the side from both side of the rail to maintain the pod to fly and travel in the same speed without drifting to any side, and that will make it very secure and safe to travel. Last year, student from San Jose State Hyperloop team designed a lateral stability system, but this system is not really authentic or very safe and guaranteed to be perfect to be used for a high intense speed due to the simplicity of the design. It's made of only one small spring and connector, and they're both attached on the same direction. And by the end, this is cannot handle too much stress and vibration, and it might affect and destroy the inside chassis of the Hyperloop. So we decided to came up with the design that you're gonna see by the end of the video. This design would expect it to be stronger and higher strength than the other designs. So we have done some design tests and analysis to our product, especially the 3-bar linkage and the shock absorber with the wheel. We couldn't do everything due to the software problems. We cannot have everything, so we used SolidWorks analysis, and we did ANSYS, and according to the data we got, we have a very perfect and safe product. And on the top of that, this our product will be very cheap and not expensive for this specific pod, not the different pods, the actual pod size, but it's not going to be too expensive, and it's going to be perfectly good to be used, and it will be safe. But there still should be some physical tests that we won't be able to do it due to the coronavirus issue, that we will not be able to meet together and work on the manufacturing and process this design. So we won't be able to fabricate anything by the end of the semester or by the end of this year because of the problem that we have. And actually we are trying to work on it, but maybe by the end of the year or whenever this issue gonna go, so we will continue and pursue the design of the project, and we will do the manufacturing. I would say the Hyperloop technology cannot be easy to design, but it's not impossible. It's a very interesting project, and it's not too complicated to make it, but it requires too much safety, and it requires a lot of maintenance in order to maintain it operating every time. This product, if it's gonna be done by the end of like 2022 or 2023, depends. Some companies offer a specific time to release their first Hyperloop design. Will be a revolution for the transportation for human, because people will be able to travel in very fast way and too cheap way, and expect it to be too safe. And on top of all of that, human will be able to see the world in a different eyes. So I hope you like this video, and I'm sorry for the low quality of the video due to the quick making because of the deadline. I hope you like it, and please feel free to ask me or my teammates. I will put the emails of my team and me and my professor if you have any concern. Thank you so much. Feel free to contact us. Thank you so much. Have a good day.